Problem 17 of the MIT Integration Pre-Qualifying Exam Tier 13 is the indefinite integral of 2 natural logarithm of x plus the natural logarithm of x squared. So this is fairly complicated. Let's see how we may be able to solve it. So yeah, let's look at our problem. Indefinite integral of 2 natural logarithm of x plus the natural logarithm of x squared. The complex part is the log part. So what we could do is just say let u be equal to natural logarithm of x, and that means that du dx is equals to 1 over x, and that means that x du will be equal to dx, and from here we can say that e to the power u is equals to x. So here we can then say e to the power u du can be used to substitute of dx, right? So that this integral to log x plus log x squared would be equal to integral in bracket 2 u plus u squared eu du. This here is this, and then where log is, we have substituted for u with u. So this becomes two separate integrals, 1 2u e to the power u, and then the next one I'll use color blue to just delineate. So we have the integral of u squared eu du. We're going to use integration by parts, and let's solve one integral at a time. Integration by parts tells us that if you have an integral of v du, the product of v and the derivative of u, that's the same as the product of u and v minus u dv, right? And so for the yellow integral here, 2, we can take u as v and eu as du, and the derivative of eu is the same as eu. So is equals to 2 eu minus dv is u differentiated with respect to u, and we're left with that. So which becomes 2 in bracket u eu minus eu plus the integration constant. Now let's look at our blue, and our blue integral is u squared e to the power u du, and we take this to be v and this to be du. So this becomes u squared eu minus the derivative of u squared is 2 u eu du, and this becomes u squared e to the power u minus 2 in bracket u, a chain approach, right? So it becomes u squared eu minus 2u e to the power u plus 2 eu plus the integration constant 2, right? So we're going to combine our integrals, where we have 2 u e u, and then plus, right? And let's use green, maybe just 2 EU minus EU plus U squared EU minus 2 U EU plus 2 EU, and then we can just add the constants as a big C, and we're quickly able to see that this goes off with this, and then this cancels out with this because there's a 2, and so we're left with only this part here, right? So in other words, our integral has become U squared EU plus C, but we say that U is equal to log X. So our integral of 2 log X plus log X squared dx is equals to log X squared in place of U e to the power log X plus C. E to the power log X is the same as X, so in other words we have log X squared, X log X squared plus C. And here, ladies and gentlemen, is our answer.